Okay, good morning, everybody. Hope you're doing well. I'm going to cover page 7. I lost a page here. I'm sorry. Page 387, 7 through 29 odd with you today. So let's get started. It says rewrite for number 7 and number 9. It said to rewrite the logarithm as a ratio of part A, common logarithms, and then part B, natural logarithms. So very simple to do. The change of base formula tells us that if we do log of 16 divided by log of 5, that is going to give you a answer. Now, they didn't want us to actually get the answer. They just said rewrite it as the common log. The common log is base 10. So as you can see, there's no log written there. Therefore, it's the common log. So this is number 7. That was part A. Part B to number 7 was the natural log. So same thing, just natural log of 16 divided by natural log of 5. Number 9's equally as easy. They wanted you to do, you're going to have, excuse me, log of 3/10 divided by log of x. And then for natural log, it's going to be natural log of 3/10 divided by natural log of x. Okay. Now for number 11, it said evaluate the logarithm using the change of base formula and round your answer to the nearest tenth. So for that, I'm just going to need to get a calculator. Unfortunately, I'm having issues with my connectivity between my iPad and my laptop. So I am not going to be able to show you work on my laptop while I am completing the homework, unfortunately. So on your calculator, all you would do for number 11 is to write, and I can write this down, but in your calculator, you would do log of 7, and you would divide that by log of 3. And when you do that, log of 7 divided by log of 3, you get 1.7712433749. Keeps going on for a while. Asks you to round to 3 decimal places, so it'd be 1.771. Okay. So that was number 11. Number 13 is going to be, we're just going to do log of 0.1 divided by log of 9. And give me 1 second, type that in. Log of 0.1 divided by log of 9. You get negative 1.04, and that would round to an 8 because it's 7/9. So that was number 13. Number 15 says in exercises 15 through 20, use the properties of logarithms to write and simplify the logarithmic expression. So what we have here is we have log base 4 of 8. Now, I believe what they want you to do is to take this, make this log base 4 of 2 times 4. And then from there, we can split this using the product property into log base 4 of 2 plus log base 4 of 4. Now, this part right here, log base 4 of 4, that turns into 1. Anytime the base of the log matches the number that's being logged, it's 1. So we're just going to have log base 4 of 2 plus 1. And this is your final answer. You do not add the 2 plus 1 because the log would need to do its thing first. Following PEMDAS, keep in mind logs are members of the exponential family. So therefore, you could not add the 2 plus 1 before you actually took log base 4 of 2. And we can't do anything more with that. So we are done. Number 17. asks you to do log base 5 of 1 over 250. Now, 250 is not a power of 5, but it can be broken up into 25 times 10, which is what we're going to do here in a second. So let's make this log base 5 of 250 to the negative 1. And now the power property allows us to bring that ahead. Log base 5 of 250. And that's negative 1 log base 5 of 3. Sorry, that's not right. Back that up. 2 times 125. And so by doing that, actually, I'm going to start this one over. I'm going to do this one a little different. Because I think this one's going to be confusing if I do it this way. It would have worked, but I'm going to start this over, and I apologize. I want to do this way. So we're going to make this log base 5 of 1 over 2 times 125. The reason why we going with 125 is 125 is a power of 5. So kind of to key in on these problems, when you're looking at the number that's being logged, you want to see if it can be written as a power of the base of the log. So in this case, 250 is not a power of 5. However, 2 times 125 is 250, and 125 is a power of 5. So then this becomes... we're going to use the quotient property. This is going to become log of 5, log base 5, excuse me, of 1 minus log base 5 of 2 times 125. Now from there, we're going to use, right here, we're going to use the product property to split that up further. So this is going to be log base 5 of 1 minus log base 5 of 2 plus log base 5 of 125. Now, anytime we have right here, anytime you have log base anything of 1, that is going to equal 0. So this is 0. So log of 1 is 0, no matter what the base is. This is going to remain log base 5 of 2. And this right here can be rewritten as log base 5 of 5 to the 3rd power. Now, I'm going to run out of room here, but the 0 goes away. We have negative log base 5 of 2 plus, remember the power property allows us to bring the 3 down, and then it becomes log base 5 of 5. Well, log base 5 of 5 cancels, and so this just goes away, and we're just left with the 3. So the final answer here is negative log base 5 of 2 plus 3. And I apologize for the writing. I lost my stylus, either that or one of my kids took it. And so I'm trying to just write with my pointer finger, and it's pretty difficult. So the final answer for number 17 is negative log base 5 of 2 plus 3. Once again, the 2 plus 3 cannot combine, as you would have to take the log of 2 first, because that's part of the exponents family in PEMDAS. You cannot add those two together. Okay, moving on to number 19. Number 19 says natural log of 5e to the 6th. Natural log of 5e to the 6th. We're going to use the product property to break these up. So we're going to have natural log of 5 plus natural log of e to the 6th. Natural log of 5 is not going to change. Natural log of e to the 6th is going to come down first, according to the power property. And then you can see we have natural log of e. That is exactly the same as log base 10 of 10 or log base 5 of 5. The natural log base is e, and it is matching the number that is being logged, which is e. So this cancels, goes away, and you're left with natural log of 5 plus 6. Now, number 21, they asked you to find the exact value of the logarithmic expression without using a calculator. And it says if this is not possible, then state the reason. So I'm going to move on to another page. We have a full sheet here, 21. It says log base 3 of 9. And again, I stated in a problem we did a couple problems ago, your goal is to try to relate the base and the number that's being logged. So what we can do is we can rewrite 9 as 3 to the second. And by doing so, you can see now the base of the log matches the base of the power. So the 2 is going to come out in front of the log, and you're going to have log base 3 of 3. Log base 3 of 3 is 1 that goes away, and you're left with 2. Here is 23. 23 is log base 2 of the 4th root of 8. There's a lot going on in this one. The first thing you want to do, anytime you have a root, whether it's a square root, cube root, 4th root, you want to rewrite it as an exponent. So we're going to rewrite this as log base 2 of 8 to the 1/4 power. The next thing you want to try to do is to get the number that's being logged written as a power of the base. So our base is 2. We want to try to rewrite 8. So it's going to be log base 2 of 2 to the 3rd power to the 1/4. Now you might say, where did 2 to the 3rd come from? Well, 2 times 2 is 4, times 2 is 8. So I rewrote 8 as 2 to the 3rd. Why did we do that? We did that so this 2 of the base matches this 2, which is the base of the number that's being logged. When that happens, we're able to cancel things out. First thing to look at, though, is we have this 3 and this 1/4. These are both powers. When you have a power to a power, they multiply. So it becomes log base 2 of 2 to the 3/4. Now the power property allows us to bring that 3/4 down, and it becomes 3/4 log base 2 of 2. The log base 2 of 2's cancel, and we are just left with 3/4. Okay, number 25. 25 is log base 4 of 16 to the 2nd. We need to rewrite the 16. You kind of see how this goes. So we have log base 4, and 16 is 4 to the 2nd, and then there's still another 2nd out there. And now we have a power to a power, which we multiply those. So we have 4 to the 4th. And then we can use the power property to bring the 4 down front. So now it's just 4 times log base 4 of 4. Log base 4 of 4 cancels, and you're left with 4. 27 is log base 2 of negative 2. And this one's a little trickier. The reason being is the negative needs to be separated from the 2. So we're going to have log base 2 of negative 1 times 2. Then we're going to use the product property to split those. So we have negative, I'm sorry, we don't have negative. We have log base 2 of negative 1 plus log base 2 of 2. Now, log base 2 of 2 cancels out and turns into 1. And this one right here, though, this is a problem. And actually, we could have done this all the way up here at the beginning step. You are not allowed to log negative numbers. It is negative numbers being logged are outside of the domain of log. So this one actually has no solution. And that's because you cannot log negative numbers. All right, last one. Number 29 asks you to do natural log of e to the 4.5. This one's very easy. Power property, bring the 4.5 down. And then this is natural log of e, which is the same as log base 10 of 10 or log base 2 of 2. Natural log and e cancel, they turn into 1, and you're just left with 4.5. All right, there you go, guys. Have a good day.